briefing earlier this week on proper PowerPoint format, so take it away.
My colleague here was not here for the proper PowerPoint presentation discussion, but we're going to work our way through it. My name is Rachel, this is Corey, and we had a third member of our team who's Will, but he's not able to be here today.
We wanted to put a little bit about each other in this, so we could just kind of, you guys can know a little bit about us. So I was born and raised here. I've been working up in Alaska for the past 6 years. Started this program in 2009. Rather than be here.
The fish aren't there.
And I came over from Billings, and I've taken the program over about 3.5 years, and I'm finishing up. This is my last task, and it's well worth it. It's the curriculum is awesome, and this practicum is a whirlwind of get everything to the forefront of the future. I think it's pretty cool. And Will also was finishing up, like maybe a year more for him to do.
Yeah, maybe a semester, but he's been in it since almost the beginning too.
Yeah, so he flew in from Pennsylvania, huge effort on his part, rented a house.
6-volt batteries.
I believe that was last year's practicum project.
The goal was to design a trickle charge, a constant trickle charge to the battery to power a circuit in the interior of the trailer for charging devices, provide a DC disconnect, and deploy a versatile working educational PV system.
And we put together a design matrix. It doesn't really look like it has a lot of common sense to it when you look at it, because what we ultimately picked was the most expensive and the most time involved.
We picked this one, high, moderate.
But originally we were charged with mounting 2 panels on the energy trailer, and so we went through the first 3 options for mounting 2 panels, and we were going to pick just the rear swing gate, which at the moderate complexity, moderate time, moderate versatility, and the okay cost. But because we got some donated materials and we just really got into it, we decided to double what we were doing, and I think we got a lot more bang for our buck actually doing it.
So the design was 4 solar panels mounted on the trailer to supply a 24-volt system. So we worked with colleagues that are designing a cooling system for the PV panels.
That's the next part after us.
The design was modeled using a 3D printer prior to building it, and measures immediate charging. Okay, so 2 racks were constructed and installed on the trailer. The solar panels were attached to the racks and wired into the system using a DC disconnect and a charge controller.
Is your 3D print handy?
What happens to the actual piece, you mean? So that's a 3D model that's going around.
This was all new to me. I did not know AutoCAD at all going into this practicum, and I pretty much took it on day one. Just YouTubed a lot of videos and started kind of figuring it out. And these are the 2 designs that the 3D printer that we actually were able to print, and it is roughly the same scale as the actual PV system out there. So it was really cool. It was measured to inches. It basically 75 inches long, and then that's 7.5 inches long. So it ended up looking really nice. Took me a long time.
What was the print time on that?
Well, the print time, it was
4 hours,
a little skewed because one of the pieces was not associated with this, but it would have taken about 2 hours without that piece, about an hour a piece. So this is the drawing, and then that's the actual print. So it came out well. It's I don't know. It's a process. You know, convert files and then send it to the printer. And I wish I was able to put a couple other pictures in here, but Garden City Plumbing and Heating helped us out a lot with the frame. They donated pipe and fittings. Went to high school with Kyle here, who works with Garden City, and we were able to put the frame together one night. So that pretty much made it possible for us to both have the rear gate mounts and the roof top mount. So I think we'll have to get a Garden City sticker on the side of the trailer at one point.
Nice.
So the gate was designed to be versatile. If the trailer is parked due south, we can keep it attached, basically swing it out so that it's just across the back of the trailer. And then if it's, I guess if it's turned, facing west, we can still get it to face south by swinging it out 90 degrees. So
You don't always have optimal parking options, I suppose, when you take the trailer around.
it's also on hinges, so we had kind of thought about creating just a ground mount for it, which it would not take much at all. So if we don't get to it during this practicum, we'll get to it eventually, where you can just lift the gate off of the trailer and then turn it however you want to and mount it on just on that ground mount. So.
And it stores up against the wall when it's traveling.
And then this is a picture of the roof mount. Basically, the frame was welded, and so we were able to create a ability to basically put two upright beams to get it to a 45, and then also be able to put it down so that it can travel safely on the highway.
This is our existing setup when we came into the project. It's a wind turbine setup that goes through a charge controller into an inverter and the battery bank, and had a dump load of a heater. So when the batteries are full, the extra charge goes over to the dump load and produces a lot of heat. Well, hopefully a lot of heat. The turbine's running.
And then that was going to an AC or an inverter to power an outlet.
And in our design with the gate mount system, we have two panels mounted on a gate that are joined in a junction box, go through a DC disconnect, which we added because there wasn't one before, and the charge controller. And this little thing on the bottom is the fans that Rob and his group will talk about later. They're powered directly by the solar panels, right?
Correct.
Yeah. And then the rest of our load goes into the battery bank, which the PV system charge controller connects to the battery string. We couldn't put the whole schematic up there, it was pretty detailed. And the roof mount's similar. And then the additional thing to the roof mount is there's a 12-volt DC charging station. That just shows the rest of it. It's kind of hard to tell, but these are the batteries. So the charge controllers coming off the solar panels to the batteries, and then the inverters connected to the batteries to switch from DC to AC power.
So this is pretty much our system here for the most part.
We were on the power side. So we figured that our rooftop panels, when they're positioned at 45, will produce 138 kilowatt hours per year. And when they're flat, there's not much of a difference, which we were surprised, it's 116 kilowatt hours per year. So it's actually a pretty good deal. The angle's not so critical, and it'll supply that trickle charge to the batteries that we want to keep them constantly charged.
Be able to charge the batteries while we're driving somewhere.
And then the whole system, 276 kilowatt hours per year, which is not like stellar amazing, but it's sized right for what we want it to do. So we don't want it to power a house, we just want it to keep the batteries charged, and we also don't want the dump load to be running all the time because we have too much power, so it seems like it's gonna do the job. These are our methods, working in the rain.
Thank God for tarps.
It's real fun to weld in the rain, huh?
All the work in the rain was so fun. one more page of pictures.
Rachel got really good at welding. I got really good at measuring things.
And Will
Well,
did
that's
some nice
debatable,
lettering,
but.
too.
Yeah, the wires are still nice and tight too.
And I'll add for Will, he wanted to say very, very importantly, everything is now bonded, everything is right up to NEC code, except the trailer still needs to be grounded as per NEC 214.
Good, 'cause there's a lot of exam questions on that exact topic, so.
So yeah, and our costs, we figured it's a rough estimate, but pretty close, we believe. Roof rack system with the 2 panels was $662, and the gate rack. The value of the gate rack is $980, but we probably put $625 into it. We had some donated materials. And you saw the two of them together.
That's
Pretty
nice
awesome.
photo, yeah.
And so our conclusion is we were able to install 2 120-watt PV systems. The roof mount will constantly trickle charge the batteries, and the rear gate is versatile and will be used. It's also a learning tool for future students.
And Will would want to stress that, you know, we did it all to code, nice and tidy, took pride in our workmanship, and came out with something that was actually pretty good.